Congressman Kilmer also serves as the co-chair of the bipartisan, bicameral Planetary Science Caucus in Congress, which aims to raise awareness on the benefits of federal investments in space science, technology, exploration, and STEM education to grow jobs and boost the nation's economy. And now I will turn it over to our host, Congressman Derek Kilmer.
Thanks so much, and hello everybody. I am really excited to be with you all today and want to start off by just saying hello to all the students out there in our neck of the woods. I also want to thank Administrator Jim Bridenstine and Dr. Michael Barrett for being here today and for the great team at NASA that helped make this event happen. Administrator Bridenstine may remember this story because he and I served on the Science, Space, and Technology Committee in both of our first years in Congress. And I shared this. When I was a state legislator, the Key Peninsula Middle School in our district was a NASA Explorer School. And we had an astronaut come and visit the middle school, and she had been working on the Hubble Space Telescope, and she put up on the screen what appeared to be a giant black circle. And she said, "Does anybody know what this is?" And the students started guessing. And after a few inaccurate guesses, she said, "It's a giant hole." And then she said, "Does anyone want to guess where this giant hole is?" And after a few guesses that included the moon and my neighbor's backyard, someone guessed Mars. And she said, "That is right. It's a giant hole on Mars." And she said, "Does anyone want to guess what caused this giant hole on Mars?" And the students made a whole bunch of guesses. And she said, "You know the truth? We don't know what caused it." And then she says, "Does anyone want to guess how deep it is?" And a bunch of the students guessed. And then after a few guesses, she said, "You know what? We don't know that either." And I got to be honest with you. I walked out of that gym and out of Key Peninsula Middle School and immediately got on the phone with my wife and said, "Did you know that there's a giant hole on Mars and we don't know how deep it is and we don't know what caused it?" And shouldn't that be like on the front page of the newspaper or something? But honestly, discoveries like that are part of what's so cool about space and exploration and pursuing an education in science and technology to help you get there. And I'll tell you what, I'm sure my wife Jen is going to get a full recap of our conversation today and a whole lot more information on space than she asked for when this is over. But for me, an education in science and technology is really about a few things. First, it's about discovery. It's about inventing cool stuff and discovering really cool stuff. It's about the folks at NASA and at universities and at our science centers who are working every day to find out more about our planets, our solar system, our galaxy, and beyond. It's about the awesome folks just about 40 minutes from where I'm sitting right now at a company that's developing technologies to send satellites into space and then to send human beings into space. Imagine getting to go on vacation with your family to space someday. That could happen in your lifetime. So I think it's important that you're here, and it's important for you to know that we are counting on you, all the students out there, to help do amazing things like figure out how deep that giant hole is on Mars. But it's not just about fun stuff, it's also about important stuff, and that brings me to my second point. Going to school and learning about science and technology and engineering and math is important because it's about solving important problems. For example, the awesome folks at NASA and institutions like it monitor our Earth's vital signs from land and air and space using an array of satellites and instruments on the International Space Station. They help us tackle some of the biggest challenges facing our planet today and in the future, including natural disasters and the availability of natural resources and rising sea levels and climate change. And these discoveries and research and data about our planet and our climate and about how it's changing enable policymakers like me to make more informed decisions about critical issues that occur all around the world. Finally, an education that focuses on science and technology is a big deal because while it may seem like a long time for some of you students out there to have to go get a job, it may be sooner than you think. And here's what's important about jobs in technology. According to the U.S. Department of Commerce, jobs that are related to science, technology, engineering, and math, what we call STEM, are growing faster than any other sector of jobs. So if you study STEM, it means you are probably more likely to get a job. And in our country, we need more of you to study STEM. In 2018, there were about 2.5 million jobs in STEM that went unfilled, and that means we need more people graduating with degrees in this field. And on top of that, STEM jobs pay more. Workers in STEM occupations earn about 26% higher wages than non-STEM workers. So if you want to be able to take that family vacation to space eventually, there's real value in an education that helps you do it. So basically, choosing to study science, technology, engineering, and math will help you down the road. So I want to say thank you all for being here today. As a dad myself, I know that it's still summer break for most of you, and you could be doing anything in the world, but today you're here with me, and together we're doing something really cool, and that's talking about the future and talking to a real-life astronaut who was born just down I-5 and is a proud UW Husky, about how you can do anything you put your mind to. But first, we're going to hear from a good friend of mine that I had the honor of serving in Congress with, the administrator of NASA, Jim Bridenstine, who also has a really cool job and is leading all of NASA and helping to build our incredible space program. So with that, Administrator Bridenstine, over to you.
Well, thank you so much, Representative Kilmer. What an honor to be with you in your district virtually with your constituents and the students that are interested in STEM. I will tell you, just for your constituents so that they know, we served together in the House of Representatives for many years together before I came to NASA, and they need to know that you are a very, very good representative of their interests. I know that firsthand, and I can also say, Derek, you are one of the brightest, most thoughtful members of Congress. I'm proud to call you a friend, and I appreciate all the amazing work that you do on behalf of not just your constituency, but the United States of America. I will also say that Representative Kilmer is not just somebody who is enthusiastic about space because, the NASA administrator and an astronaut are on the phone call here. Representative Kilmer really loves space. I can tell you that. And he's the only member of Congress that I can think of that actually has Star Wars paraphernalia on his walls in Congress. So it is truly something that is a part of who he is. I just want to say, you talked about discovery, Representative Kilmer, and this discovery of a hole on Mars. So I've been the NASA administrator now for almost 2.5 years. And I want to share with you some of the things that have been discovered just in the time I've been at NASA, which if you look at, the history of NASA, it's almost nothing. But think about this. We have learned just in my time there that Mars is covered in complex organic compounds. In other words, the building blocks of life are all over Mars. They're not on the moon at all, but they're all over Mars. And of course, they're all over Earth. We have also discovered that the methane cycles of Mars match the seasons of Mars. What does that mean? Well, what it means is that the probability of finding life on another world has just gone up yet again. We're now seeing massive plumes of methane coming from Mars that make people believe that there could very well be, and I'm not saying there is because I'm the NASA administrator, and until we make a discovery, I don't want to declare that a discovery has been made. But they're very well, it could be geological in nature, but it also could be biological in nature, these massive plumes of methane that are coming from Mars. We've also discovered what very well could be liquid water 12 kilometers under the surface of Mars. What do we know about liquid water on Earth? Wherever it exists, there's life. Is that true on Mars? We don't know, but we need to go find out. I really believe that if we were able to discover the presence of either life or ancient life on another world like Mars, it would fundamentally change how we think about space exploration. All of a sudden, humanity in general would be so excited about what we could discover out there, not just around another star, but in our own backyard, in our own solar system. I tweeted this morning about Ceres, which is, they call it a dwarf planet, but it's on the other side of Mars in what's called the asteroid belt. And we have discovered on Ceres, what they call, vents, thermal vents. So Ceres used to be a water world. We think of Jupiter has a moon called Europa. It's an entire world that is water. And now we have what looks like with an ice shell, which means that what's inside that ice shell would be protected from the radiation of deep space. In other words, there very well could be life inside of Europa, which is basically a moon of Jupiter. And now Ceres looks like it's in the asteroid belt, but it looks like it would be very, very similar to what Europa looks like today. Although billions of years ago, it lost its ice shell, it lost its water, and now it's what we believe the inside of Europa would look like. But my point is this: we're making so many discoveries so fast, and it's so exciting. The goal is this: we need to get humans to Mars. That's what we need to do. The best way to do that is to go to the moon. The challenge with Mars is that Mars and Earth are on the same side of the sun once every 26 months. So if you go to Mars, by the time you get there, you're not going to be able to come home for 26 months. So we need to learn how to live and work on another world for long periods of time. And the best place to do that is the moon. And that's why we've created the Artemis program, which is our sustainable return to the moon so that we can eventually get to Mars. And when we think about the moon, about 10 years ago, we discovered hundreds of millions of tons of water ice on the south pole of the moon. Water ice represents life support. It's air to breathe. It's H2O, oxygen. H2O is oxygen. So the oxygen is air to breathe. H2O is water to drink. Hydrogen is in fact rocket fuel, and it's available in hundreds of millions of tons on the south pole of the moon. So we need to go to the moon. We need to learn how to live and work on another world using the resources of that world to live and work for long periods of time, and then take that knowledge. The glory of the moon is it's always a 3-day journey home, which means things can go wrong and you can still come home. We learned that on Apollo 13. I know many kids maybe on this call watched the movie Apollo 13. So that's what the Artemis program is all about. We call the program Artemis because in Greek mythology, Artemis was the twin sister of Apollo, and we love the Apollo program. That was Neil Armstrong and Buzz Aldrin walking on the moon, as well as 5 additional moon landings with 12 people total walking on the moon. We love the Apollo program. But in the 1960s and the early 1970s, all of our astronauts came from fighter pilot backgrounds and test pilot backgrounds, and in those days, there were no opportunities for women. Well, today we have this very diverse, highly qualified astronaut corps that includes women, and we go under the name of Apollo's twin sister. Her name is Artemis, and this time we get to go to the moon with all of America. And in fact, we're going to go with a coalition of international partners. So this is going to be the most diverse coalition of nations, and of course all of America going to the moon to make more discoveries than ever before, but ultimately with a purpose to learn how to live and work and then go to Mars. So I would encourage everybody to look, stay tuned. We're doing big things, and Representative Kilmer, I appreciate you being willing to do this town hall. I would also say it's also important to note that Representative Kilmer is an appropriator. So he writes the checks that help us do what we do, and we're very grateful for your long and steadfast support of America's space program. Thank you so much, Representative Kilmer. I now get the chance to introduce Mike Barrett. Is it all right if I do that, Representative Kilmer? So Mike Barrett is, I should say, Dr. Mike Barrett. He's a medical doctor, but he studied undergraduate there at the University of Washington. And interestingly, he studied zoology. So we think about, if you want to be an astronaut, you're out there watching today, what do you need to study? The first thing that comes to mind might not be zoology, but that's what Dr. Barrett studied. He went on to become a medical doctor at Northwestern University, and eventually became a NASA astronaut. He's a veteran of two missions, one of which was a space shuttle mission, and the other one was, correct me if I'm wrong, Dr. Barrett, was it a Soyuz or was it a different space shuttle mission for the space station?
No, it was a Soyuz mission indeed, 199 days on station.
Okay, so just know that you're talking to an American hero here who's done astonishingly impressive things in space, and because of his hard work, we still have, in November, Think about this. In November, we are celebrating 20 years of people living and working in space. So I'm looking at all of the participants on this teleconference. There's a good chunk of these participants who have never lived a day of their lives when we didn't have humans living in space, which is amazing. So, Dr. Barrett, I'll turn it
Thank you very much. I really thank both Administrator Bridenstine and Congressman Kilmer for giving me the opportunity, first to speak about something I really like, I really love, actually. It's a big passion. And second, to speak it to a lot of people that I really like. As mentioned, I'm actually one of you. I'm a native of Washington State and very proud of that. And I have to say that after listening to Mr. Bridenstine and Congressman Kilmer, I'm actually pretty psyched about this now, too. So what I want to do is show you a quick deck of slides, which will sort of outline a little bit of my personal journey. And as soon as the overlords give me permission, I will do that. And it is going to be very much centered around a showpiece program that Administrator Bridenstine has mentioned. Now, I'm calling this STEM, Artemis, and you. I'm going to do this a little bit in reverse order. It's going to be more like me, Artemis, and STEM, because again, I think kind of giving you my personal journey on the way here might make it a little bit more relatable to you. And believe me, if you don't come out of this thinking that this applies to all of you too, then I've not done a very good job. So let me get three things out of the way first. First thing is, you guys live in the best part of the planet, okay? I love this section of the world. It's my home. It's my family. I took, I think, 29,000 pictures during my first mission up there, and probably more than half of them were of this area, at least when the weather was good. There was a lot of them, as you might guess, was just kind of cloudy. But I really, I envy you for being there, and I get home any chance I get. Second thing to get out of the way, Washington State simply rocks in space, okay? This is Colonel Ann McLean. This was her last spacewalk practice in our big neutral buoyancy laboratory, our big water tank where we practice spacewalks at the NASA Johnson Space Center. And I got to be her running mate on that and kind of put her through her paces. Now, Ann McLean is a country-class rugby player, a very, very tough girl. I think I could still kick her butt in the pool, but at the end of the day, she went and did a CrossFit workout, and I think I went to lie on the couch and cry. But, you know, she just is really amazing at what she does, and she flew a mission absolutely brilliantly. This is one of our newer astronauts, Kayla Barron, who's from Richland, Washington. And just to be very upfront about it, there's a lot of us from the great state of Washington. And this is the people who kind of call Washington home. There's a slew of others that adopted Washington as their home. So it's a big thing, and we're kind of organized, as you might guess. Third thing I want to get out of the way is, as mentioned, I am a medical doctor. And when I was very, very small, my grandmother was watching Star Trek, and everybody else really liked Captain Kirk. To me, the hero was the guy in the middle. Now, a lot of you guys online probably don't know who this is. Hopefully the adults do. This is Dr. McCoy, Leonard McCoy. And he was the ship's doctor. And the very idea that he had to take care of creatures, people of sorts, from different planets with different anatomy and different physiology, I found that really quite intriguing. I thought, boy, wouldn't it be great if there was such an opportunity? And every great Star Trek franchise since then has always had a really good, killer doctor, and that's kind of the expectation. So my passion, absolutely, is the human in space, how we adapt, how we work, how we thrive up there, and it's important because it's how we're going to explore and how we're going to get somewhere. Now, on a little bit to my personal path, this was a little house I grew up in on a farm down just close to the Columbia River east of Vancouver, Washington. Yeah, it was all black and white back then. It was very dreary and dull. Not true. That's just the photographs that we had back then. It was a perfect upbringing, though, for preparation for spaceflight because you learn to fix things all the time. You learn discipline and chores and everything that went with raising farm animals. We had about 80 acres or so. And I'll skip my elementary and middle schools, but I went to Camas High School and graduated from there. This is not the school I graduated from. A few years after I left, they built this beautiful new building. But I'm really proud of the educational system that they have there today. So I finished high school with a lot of diverse interests, and as Mr. Bridenstine said, I went to the University of Washington and I majored in zoology with a marine emphasis, actually. Now, by that time, I had already gone through several stages of career anxiety, wanting to be either a paleontologist because dinosaurs were cool or an astronomer. I built a lot of telescopes. And then ocean science just really floated my boat, actually. So 4 years here. It was a wonderful place. I met my wife actually here. We were married in undergrad. And as you all know, the cherry blossoms bloom all year round up there. It's just gorgeous like this all the time. Not really. Then I went to Northwestern University Medical School. So that's a bit of a departure, as you might think, from some of the things that I mentioned. But as I started putting all those together, the idea that it's the human that functions in all of those environments started to really take seed in me and make me think, what is the human like and how do we adapt? So I did 4 years of medical school, and then I did 4 years of internal medicine training to learn pathophysiology, to learn about the process of health and disease. And if that wasn't enough, I then did another 2 years at Wright State University in Dayton, Ohio, and that was in tandem with the Wright-Patterson Air Force Base. And I got a residency and a master's in aerospace medicine and aerospace physiology. Now, please don't try to do the math. I can just tell you that that was 10 years of extra training beyond college. Don't be scared. You don't need to do that. That's just the path that I took. But I can tell you that the further you go in your education, the more fun, the more engaging, the more stimulating it really is. And then I came to the NASA Johnson Space Center, and that's been my home now for nearly 30 years. I've really not left except to do NASA-related business. And I spent my first 9 years there as a NASA flight surgeon. And that was a really great time. It really embodied everything I loved. It was a bit of flying. It was medicine. It was training people to do medicine who weren't medical doctors themselves. It was research. It was very international. And this is one of my favorite pictures because on the far left there is Norm Thagard. He was the first American to fly on a Soyuz, and he flew to the Mir station as we were just starting working with the Russians, who have become our very good colleagues now over the decades. My good friend David Ward on the far right, who is also a NASA flight surgeon, and in between us is space superwoman herself, Dr. Peggy Whitson. And this was at a time when she was the medical science lead for the U.S.-Russian program. I was the medical operations lead. Neither of us were astronauts at that time, but lo and behold, we both became astronauts. And that was a really tremendous background for us to carry forward. And I did join the astronaut corps with 16 of what have become my closest friends in the year 2000. Now, a couple of these folks, Doug Hurley and Bob Benkin in here, are my classmates, the Bugs, the Millennium Bugs, as we called ourselves, just landed from the first Crew Dragon mission from space station. So we're real proud of them. And I think our class has really made its mark. Well, every class thinks that, but ours really has. I want to point out that once you join the astronaut corps, it's not just learning about space. It's really building all the tools you need to make space work for us and to understand why we're in space in the first place. And to do that, we learn to explore the Earth. We do a lot of wilderness training, partly to build the expeditionary behaviors of working in austere places and working as teams, but we actually do real science in these areas. And so you get used to having to do specimen collection or identification or even some laboratory techniques in the field along with these somewhat harsh conditions. This is just up the coast of British Columbia. Having grown up in the Northwest, I was kind of a bear in a honeypot here. So to me, it wasn't so hard, but anyway, it really helps us, and that's one of many things we do. This is Arctic training, where we're out there in very cold weather, pulling a sled that weighs a couple 100 pounds, and you're pretty much learning reliance on yourself in harsh conditions. But again, you're expected to do science. We have an underwater habitat that we use off the coast of Florida, the Aquarius habitat. It's very similar to a space module, and actually being out on the reef diving is very similar to a spacewalk. It's one of those venues that probably most closely approximates real space flight that we can actually still do on the ground. And you learn critical dependence on your teammates and your gear and everything around you, your life support system. And those, again, are very good tools to carry into space. Another thing we do is a caving experience. I spent a week basically underground in the Sagruda cave system in Sardinia with a very international team. Again, that dependence on your gear and your team are critical, but we actually discovered some living organisms that had never been discovered before. We were the first to bring them out and identify them. So that's pretty exciting. And again, those are the kind of skills we want people to attain and to take into space. We also do high performance aviation. I was actually a private pilot before coming to the space program. These are the T-38 tests that we fly. They are impeccable training platforms, and they're just like a regular airplane, except everything happens a lot faster, and they're just tremendous fun to fly. But they keep us sharp, make no mistake. And after lots of training, game day comes around, and this is the morning of my first launch. I'm there on the right. In the middle is my commander, who's a Russian commander. And on the left is Charles Simonyi, who actually hails partly from Bellevue. So another Washington root there, but he was actually a spaceflight participant who had paid his way into space, and it was his second flight. Now, Charles is not just your typical space tourist. He was a type-rated jet pilot and a PhD computer scientist. A very brilliant man. We've become good friends for a long time. And I actually flew as a co-pilot in the Soyuz. So to me, it was just a tremendous opportunity and kind of a sign of the international aspect of what we do. The first launch I had was in the Soyuz out of the Baikonur Cosmodrome. One number I'd like everybody to take away is that we need to attain orbital velocity. That's about 17,500 miles an hour. That's how fast we have to go to establish a low Earth orbit. If we go too slow, we can't stay up there too fast, and we'll fly off to the moon when we don't want to. And that happens in about 8.5 minutes, 8 minutes, 45 seconds. So if your parents ask you, what did you learn today, you just ask them, how fast do you think you need to be going to be in low Earth orbit? And you know the answer, 17,500 miles an hour. My second launch, this was on the Space Shuttle, and the last launch of the Space Shuttle Discovery, actually. It was a kind of a bittersweet time, but absolutely beautiful machine, a flawless mission, and just another tremendous experience. Guess what? You still have to go 17,500 miles an hour. Compared to the Soyuz, this was a huge stack and a pretty shaky ride up, but boy, you sure got a smooth landing. And this is the most popular destination in low Earth orbit, the International Space Station. I actually took this picture from the Space Shuttle Discovery, and it was an interesting coincidence because we had several cargo vehicles docked at the time, and we had a very large pressurized interior, the largest in history, and that record still holds. The station is magnificent and it's huge. This gives you an idea of how big it is compared to a football field. And this is my first day on station after 2 days flight in the Soyuz. And it was great to see my friend Koichi Wakata, a Japanese astronaut who I had known for at least 10 years by that time, and start getting used to that most novel of environments, which is zero gravity. You can see my friends here have food packs that just arrived on a Progress freighter vehicle, and you let go, and they just float. And you have a lot to learn about managing yourself and your things in zero gravity, but you need to learn it quick because our big job up there is doing science, and that is really our focus. The station is an incredibly well-equipped laboratory. We can do all sorts of biological and medical experiments, which is, of course, my forte, but we also did a lot of physics, combustion, basic science, basic biology experiments. And one of the things we often did was have to take blood from each other as the onboard medical officer. It was my job to draw blood from everybody else about once a month, and of course I had to do myself. But really, whatever techniques you learn on the ground work fine up there. It's just a big science laboratory. One thing we have to point out, though, is it is a bilingual laboratory. Everybody has to be proficient in English and Russian. And this is my friend Kate, who's holding an instruction book on flying the Soyuz, which is only in Russian. There's no English subtitles in that vehicle, and so everybody who flies as a co-pilot certainly has to be pretty proficient in the Russian language. Because our bodies start losing bone and muscle and fitness, we have to exercise about 2.5 hours every day. So this is resistive exercise that we do, really heavy exercise to keep muscles and bones up. We have bicycles. This is my friend Dr. Karen Nyberg, who's just actually a pretty mean athlete herself. She's tearing it up on the cycle, and Sunny Williams, who's tearing it up on our treadmill. And it's really important to do that, to keep as fit as possible so that we can land and be more or less normal as quickly as possible, or if you think about it, so that we can land on Mars and function and get out and explore. I was lucky enough to do a couple of spacewalks. I was very fortunate in that Gennady and I were the first ones to take out the new generation Norlon MK spacesuits. They were fabulous spacesuits, and it was just an exhilarating experience. And of course, nobody tires of looking at the Earth. There's no borders. You just look down there and you have to learn geography in a new way. Only natural landmarks, coastlines, rivers, mountains. And it really does give you an appreciation for the fragility of our planet and the beauty of it, no question about it. Two contrasting views, desert on the right, coral reef on the left, and you can never tire of looking at this. If you really want to see the footprint of humanity, though, you look at night, the cities at night, and the lights along the coastline. That really tells you where those political borders are. This is Cairo, and that's the Mediterranean Sea above it. And you can also see here how thin and how fragile that atmosphere really is. So I'll just tell you that 199 days has gone by on my first flight, and it's time to land. The Soyuz punches off and lands on a single parachute. This is not us, but it was, I think, a better photograph, the Expedition 42 guys, just before the Soyuz was descending through a cloud deck. And it hits the ground pretty hard. So just before you land, some soft landing engines fire. That's the smoke and flames down there at the bottom. But it's a very, very capable system, and smelling fresh air for the first time is just an amazing experience for us. I didn't miss any of this while I was up there, but once I got down, smelling that fresh air and hearing voices of other people was just an incredibly pleasant thing. The shuttle would land quite differently, more like an aircraft, and so it was a very smooth, controlled landing and a very different experience. But again, really good to be home, good to see friends and family. So what are we doing now? One thing I would really like to point out to you is how unique the time you are living in is. So right now, we are building the SpaceX Dragon, which just flew its first successful flight with crew, the Boeing Starliner, which we hope to fly with crew next year. We've got the Sierra Nevada Dream Chaser, the little mini shuttle there to the left, which we're on contract with to provide cargo to the station. And hopefully that will become a man-rated vehicle as well. And then the Blue Origin New Glenn capsule, which is under development just up the road from you guys in Kent with our friends at Blue Origin. Now, what I want to point out is that there has never been a time in history where so many different human-carrying spacecraft were being built, not just envisioned, not just PowerPoints, but metal-bent spacecraft being built and flown. It's a really, really unique time. And that is bolstering our ability to operate and sustain things in low Earth orbit. And that's just been an incredible enabling force for us. However, the focus of today is actually beyond low Earth orbit. And what we wanted to do for a long time is to break orbit and go explore elsewhere. Now, the last time we were on the moon was 1972. That's a long time ago. It is time to get back to the moon again and to start our path again outward. And that's what the Artemis program is all about. It's NASA's lunar exploration program. Now, in this last century, there were a lot of reasons why we needed Apollo. It helped our nation come together at a time when there were a lot of divisions, they sound familiar to you, and a lot of other world events that were going on that weren't necessarily very pleasant. And yet, this was something that every American could really rally around. And of course, landing people on the moon was an incredible achievement, and some would say the most spectacular human achievement in its history. For today, we need the Artemis program. Many of the same reasons. There's an innate drive to explore. We understand that. But there's other returns that Apollo helped us realize and we've had on hold for far too long. That is advancing science, advancing our civilization. There's humanitarian aspects of it, there's diplomatic aspects of it, and potentially commercial aspects of it. One is that we may find useful products on the moon and elsewhere in the solar system. But the other thing is if we are resolved to go forward out in the solar system, the moon becomes a much cheaper place to launch from eventually and to operate from than the Earth with this very heavy gravity. And one case in point, the moon is just a very interesting place, way beyond what we thought back in the Apollo era. As Administrator Biden said, we found water in the permanent shaded areas there. there's probably abundant water ice, which gives us oxygen to breathe, water to drink, potentially rocket fuel with the hydrogen and oxygen. We've also found lava tubes that can go for many kilometers underground that potentially could provide a ready shelter from some of the radiation that's there. There's aspects of geology on the lunar surface that are still surprising us. That will help us understand the Earth much better. And of course, with 1/6 gravity, the possibility of launching heavy payloads from the moon is very enticing to us. And this is where we would like to go, to the South Pole, which is up there in the upper left. The Schrodinger impact crater is actually one of the largest features on the moon, and it shows you how rough the terrain is. So this is something we have to learn to deal with. This is going to be a lot more of a challenge, actually, than what we had in the Apollo era. But the enticements at these places, the water ice and the novel geology, really draw us out there. So what tools do we need to get there? Well, the first thing, a big rocket. The Space Launch System will be a huge booster, kind of in the Apollo class. And then a new capsule, one very different from the others that I just showed you, that's designed to go beyond low Earth orbit like the Apollo capsule, but is twice as big as the Apollo capsule by mass, and will carry 4 people, and 4 people could potentially live in this for 21 days. And as you can see, it's got solar power, which will be a big comfort point rather than the fuel cells that we had in the Apollo era. And we're also building a station, the Gateway Station in lunar vicinity, that will give us a lot of flexibility in landing on the surface. What else do we need? We need a lander. We have 3 possible contenders that we're working with right now. Different enterprises are building these. And believe me, that is a huge part of my day, is working some of the medical and human factors issues with these new vehicles. It's a very exciting thing. But we need something much more robust and much more capable than the lunar excursion modules, which did perform brilliantly during Apollo. But we're going back to stay. We're going back to inhabit the moon. We're going back to do earnest science and figure out how we can best make the moon work for us. And this is really the big picture. Artemis is our next step. It's our lunar exploration program, but you have to think about it as a long stride on an amazing path outward. Eventually exploring more of the solar system, figuring out what we can use, figuring out what we need to know about the solar system to help us ensure our civilization thrives. Now, a little bit, and I'll finish up with STEM. When I was your age, I don't think I could spell STEM, so I really am excited about the way this is developed. Science, technology, engineering, and math. I'm going to ask one question first. How many of you think STEM is only for scientists and engineers? Show of hands. I can't see you, but I'm using the force. So let me tell you, we need scientists and engineers. Make no mistake. One of my childhood heroes said this in a brilliant article in 1990 in the Skeptical Inquirer. Carl Sagan, he said, "We live in a society exquisitely dependent on science and technology, which hardly anyone knows anything about science and technology." And some would say that's gotten a little bit worse for now. Science, technology, engineering, math is for everyone who lives in our society, because our society is so intertwined with science and technology everywhere. It will help you understand your world. It will help you cast your votes on political issues. It will give you tools to educate yourself further. It really is for everyone. But having said that, again, we really do need dedicated scientists and engineers for the space program. Now, second show of hands, you think you have to be a genius to work in the space program? Well, I can tell you, this is the relative roles of hard work and genius. And most of us, and I can guarantee you, I'm no Einstein. My wife would corroborate that. Most of us are where we are at NASA now because of determination and hard work. And I don't want anyone to think that you are not smart enough to work for NASA, to work in the space program, or any other science or technological program. It's just how dedicated you are and how much work you want to put into it. And that is really who we are still. And your goals are really tied to that work. And what I will tell you and leave you with is that STEM education will give you the tools to realize many different dreams. But selfishly, I hope that those dreams lead a lot of you to us, because we really do need bright young people to do all the things that I mentioned. That is our future. And as the administrator mentioned, our next destination after Artemis is Mars. and there's all sorts of reasons to go to Mars, not the least of which is the potential of finding that we're not alone. So with that, I will yield the floor, and I will ask the overlords to deny me permission and move the crystal ball, and get us rolling on the questions.
Thanks so much, Mike. We got a number of students who wrote in with questions in advance, and we'll just dive in. And the first was for Administrator Bridenstine, a student at Washington STEM, wrote in, and you touched on this a bit in your opening remarks. Do you think we should prioritize human exploration of Mars or focus on establishing a presence on the moon? And what are your reasons?
Yeah, so this is an important question, and it's something that not just me, but a lot of people think about all the time. The goal is ultimately we want to have humans on Mars. That's what we want to have. But we also have so much to learn from the moon itself. When we think back, at the late 1960s, early 1970s, we're very excited about the moon. But today we have so many more capabilities to make discoveries. And I'll give you some examples. The moon, the Earth has a very active geology, a very active atmosphere, a very active hydrosphere, if you guys are studying the water cycle. In other words, anything that impacted the Earth billions of years ago is not today where it was billions of years ago. It's been mixed up and moved around. And so there's a number of things. Number one, subatomic charged particles that come from the sun, most of them never impact the Earth because we have this strong magnetosphere, so the particles go around the Earth. And when we think about asteroid impacts, asteroids burn up in the atmosphere of the Earth before they impact the Earth. And when they do impact the Earth, is a machine that basically makes them so that today they're in very trace amounts. We call them rare earth metals. This is what's fascinating about the moon. It doesn't have a magnetosphere that protects it from the radiation of the sun or from deep space. It doesn't have a hydrosphere. And it doesn't have an atmosphere. And it doesn't have an active geology. It doesn't have plate tectonics, for example. So anything that impacted the moon billions of years ago is today right where it was billions of years ago. And when you think about these very precious metals, platinum group metals, very valuable resources here on Earth because they're so trace, they could be found in large quantities on the surface of the moon. Now, do we know that? No, but if you're a mathematician and you do the probabilities, there's a big chance that there's a lot more rare earth metals on the moon, which I guess would mean they're not earth metals, they're rare moon metals, or less rare moon metals, as it were. But the other thing is the science of the moon, because of the subatomic charged particles coming from the sun and the radiation of deep space, the moon is a repository of data and information of the early solar system. If we really want to understand what the solar system was like billions of years ago, the moon is the place to go to get that science and that data. The other thing that's important is from the far side of the moon, we can get amazing science of deep space, what we call astrophysics. So the moon is a repository of data of the sun, what we call heliophysics. But it's also a place where we can get data from deep space because on the far side of the moon, it's extremely quiet from an electromagnetic perspective. In other words, radio waves and other waves that interfere, they don't exist on the far side of the moon. What that means is that from the far side of the moon, we can get information not from the first light of the universe, which is going to be amazing when we get, James Webb is going to launch next year to provide the first images of the first light in the universe after the Big Bang. But we can actually see before the Big Bang what we call the dark ages, and we can only see that from the far side of the moon. So the moon is a great place to go for a whole host of scientific and discovery reasons. But it's also true that we as humanity, we want to go further. We want to get to Mars. So I think it's important to say the goal is Mars, but in order to get there, we need to learn how to live and work on another world for long periods of time. But while we are sustainably at the moon, We need to use it for all of the science and information so we can get all of this knowledge that right now we simply don't have. So I think it's both. And I think it's important that we think about it as an effort to achieve both. And of course, it's something that takes time, you know. Derek, you know this. We were not alive. I don't know, I think we're about the same age. We were not alive when we had astronauts living and working on the moon. We need to make sure that another generation doesn't go by where we don't have people living and working on another world. That's up to us. That's why this is the Artemis generation. We need to say, as much as we love Apollo, it's time to have our own mission that not just goes to the moon, but ultimately with an eye for getting to Mars. Okay, I'm asking the next question. Let me look here. All right. Okay, this is from Juliana, a rising fifth grader, Olala Elementary School, and this is for astronaut Mike Barrett. 2 questions. First question, what is it like being outside during a spacewalk? And number 2, how long does it take to recover when you come back from space? So spacewalk and then recovery.
Okay, I know where Olala is, so that's a pretty little spot. So being outside for a spacewalk, first of all, you don't just open that door from scratch. You've actually trained for a long, long time, for years, to learn how to use that suit and how to do everything and how to work with your partner. You've done that in the water tank. You've done that in dry trainers. But I can just tell you that none of that prepares you for that visceral experience when you first open the hatch and you look down and there's no spaceship between you and the Earth. And a lot of folks, and myself included actually, you have this visceral sensation at first that you're falling to Earth. Now you know in your head that you're flying at orbital velocity, you're not going to fall. But that Earth just fills up your head immediately, and it's just spectacular. And then you get to work. So you could sum it up in those 2 ways. It's spectacular and you get to work. I would say it's kind of a combination of experiences and emotions. It's exhilarating, it's terrifying, you're filled with a dread of screwing up because everybody's watching you on TV, including your mom, and trying to be really, really careful because it's one of those dangerous things we do. But just knowing that there's nothing between you and space but that visor is just amazing. It's probably, I think for a lot of us, the holy grail of spaceflight. Now, how long does it take to recover? That kind of depends on how long you've been up there. So if you're up there for a long time, you attain this, what we call a state of deep adaptation to weightlessness. And you are brilliant in 3 dimensions. You become this extraterrestrial with different physiology and anatomy and different senses. But then you pay for that when you want to come home. So the more deeply adapted, the longer it takes to readapt when you get down. So it's your system of balance makes the first couple of hours not much fun when you first land. And depending on how well you've exercised, hopefully you're reasonably strong, but people do typically lose a little bit of muscle mass and blood volume. So for the first day or 2, you're like a little bowl of jelly and you don't want to walk without some help. But you gradually get better. After a couple days, people can walk without assistance, and then it's a matter of 30 days of intensive rehab before we're strong and fit as we were for the most part, and really get our balance back. So it's really fascinating to look at how people adapt and then have to readapt. Good question.
Okay, for another good question, Mia Stitt, who's a Peninsula High School student, wrote in and asked, how could a student become involved with the next mission to the moon?
That's a great question. So there's many different ways, but I think for a high school student, we have a number of contracts that NASA has put forward with universities to help us understand various aspects of the moon environment and prepare not just NASA to go to the moon, but also prepare students to become part of the workforce that will enable sustainability on the surface of the moon. I'd have to go back and look at what those schools are. I do know that the University of Washington is one of those schools. Just recently, we put out an award to 6 universities, and the University of Washington was one of those universities where we're turning to the school for a challenge for the students to get involved in activities that will help us be sustainable on the moon. I can't specifically remember what the contract was for the University of Washington, but you can go to the NASA website. In fact, you could probably just Google University Support Artemis, and you'll probably find all kinds of information. And a lot of these schools that we've contracted with from a university perspective, they also have other university partners. So if you're in high school right now and you're interested in maybe going to college and being involved in the Artemis program, even as a college student, there's opportunities to do that. And I would encourage you to visit the NASA website to learn what some of those opportunities are.
I would just maybe add a couple things. I absolutely agree with that. I've had interns and students, and we always are better for them. But remember that the first mission to the moon is the start of a program. This is going to be going on for a long time, and you can join when you're ready. Having said that, if you're interested in this, and I hope you are, I would just charge you to learn everything you can about the Artemis program and then tell everyone you know. There's a lot of information available, and you kind of become the local authority in a way if you learn every detail of it. And then you can explain it to a lot of people who aren't going to invest that time in it. You can kind of become a spokesperson for us. And I would also, I would posit that gives you a lens through which to focus your STEM education. It makes a lot of that relevant as you go through learning science and technology.
I guess I'm going to...
Yeah, we have time for about one more question before we turn it over for closing remarks.
Okay.
Mr. Administrator, I feel compelled to jump the queue here because Ivy, I think, has really the exciting question. 8th grader Ivy wants to know, what do we know about aliens or life on other planets? And I feel like that question has to get asked.
Yes. This is an important question. And by the way, you would be shocked at how many times I get this question as the NASA administrator. So here's the thing. I talked a little bit earlier, I talked about Mars and the fact that we now have methane cycles on Mars that match the seasons of Mars. We have complex organic compounds all over the surface of Mars, which are the building blocks for life. And the fact that there very well could be, we believe, liquid water 12 kilometers under the surface of Mars. You add all these things up, and it says the probability of finding life on another world, that's, a world that's quite close to us, is going up. Now, we're doing a mission right now called the Mars Perseverance rover that is the first dedicated astrobiology mission ever in NASA history. So it is going there with an intent to look for biosignatures of ancient life on Mars. Here's what we know. Because of Spirit and Opportunity, 2 rovers that are now at the end of their lives, but one was alive for 10 years, the other one was alive for 15 years. They were both designed to be alive for about a month. But they made discoveries. We now know that Mars was covered in an ocean. The northern hemisphere of Mars was ocean, like 2/3 of it was covered in ocean. We know that Mars had a strong magnetosphere that protected it from the radiation of deep space, and we know that Mars had a thick atmosphere. In other words, Mars was at one time habitable. That doesn't mean it was inhabited. I have to be really careful as the NASA administrator. But it was at least habitable. And now what we've done, we've sent Perseverance. Curiosity is there now at the Gale crater. Perseverance is going to the Jezero crater. The thing with Jezero, this is a crater that was a massive lake, the size of Lake Tahoe. And we can see rivers that are flowing into the lake. And we can see river deltas where as the water flowed into this massive crater lake, we can see the delta, and we can make assessments as to the chemical composition of early life here on Earth and how it changes the materials to the chemical composition that we're going to find in these deltas on Mars. I say all of this to say, look, the probability of finding life continues to go up. Was it there? I don't know. But I can also tell you that Mars is one of the more interesting places in the solar system. It's also unique in the sense that it's sufficiently close that we can go and study it right now. And I can also say that if we look at the moons of Jupiter and the moons of Saturn, there's a number of worlds that are out there that are, the size of our moon that are pure water. We're talking about water worlds with an ice shell, which means that the ice shell protects the inside of that planet that is pure water. It protects the inside of it from the radiation of deep space. So the question is, in our lifetimes, are we going to be able to find either signs of ancient life or even life today? And the answer is we don't know, but we're putting together an agenda to find out. And that's, I'm just, for me, Representative Kilmer and your constituents, that's the one thing that gets me the most excited. The idea that we would find life on a world that's not of Earth, which would be just an amazing discovery. So, people talk about aliens. I'm talking about, at this point, when we talk about Mars, we're talking about microbial life. I want to be clear. We're talking about very small, single-celled organisms. We're not talking about finding bunny rabbits on Mars. Although that would be really cool, that's not what we're thinking about Mars right now. But certainly, this is the other fascinating thing. The James Webb Space Telescope is going to help us see not just out into the distance of deep space, but we're actually going to be looking back into time. I know that sounds weird. I don't fully understand it myself, but the early light in the universe, as the universe has expanded, that early light has now expanded to be in infrared. And with the James Webb Space Telescope, we're going to see that first light in the universe. But even better, we can look at stars in deep space in our own galaxy. We can look at stars, and we can see as planets are orbiting those stars, we can see the light that comes through the atmospheres of those planets around other stars in our own galaxy. We can see the light that comes through those atmospheres, and some light waves are going to be absorbed, and some light waves are going to get through. And so we do something called spectroscopy, where we split the light into all the colors of the rainbow. And based on what colors get through and what colors don't get through, we can make a determination as to the chemical composition of the atmosphere of planets around other stars. In other words, we're going to be able to know if those planets have a chemical composition in their atmosphere that is conducive to life as we know it. So we're going to have, in fact, targets out there in deep space where we're going to get a lot of really interesting information and data about whether or not there are habitable planets around other stars. So these are all just, I think, exciting. This is an exciting time to be at the helm of this little agency called NASA, as it's doing so many great things. One other thing, because I know there was a student that was asking about how to get involved and that kind of thing. We had, Derek, you're going to love this. We had a 17-year-old intern. It was a high school student intern at the Goddard Space Flight Center in Maryland. And on his third day at work as an intern, he was looking at, there was a binary star system that he was interested in. So think of two stars that are orbiting each other, which is cool in itself. But around this binary star system, there was a planet orbiting that binary star system. And he was able to look at the data coming from that star system, look at the data, and make a determination that that planet was actually there. A 17-year-old intern on his third day discovered a planet around a binary star system, and I think that was the only 13th planet that has been discovered around a binary star system. So look, there's lots of opportunities. If you want to intern for NASA, we certainly would love to receive an application from you. In fact, we have interns. Even this summer, we had interns. It was a little bit awkward because everybody's working remotely, but we're doing everything we can to encourage young people to get involved in what we're doing and spread the word about the great science and discoveries that NASA is making every day.
Well, while you disappointed some of my staff slightly by saying that there's not secret aliens hidden in Area 51, I think that was super cool and really interesting, and I can't wait to tell my wife that we're now going to be able to use the web to look back in time, which is amazing. I know we did our witching hour, so I want to first say thank you to Dr. Barrett. I was really grateful to you for sharing your knowledge and for the amazing work that you do. And to Administrator Bridenstine and to your team, let me just express my gratitude. Administrator Bridenstine, thank you for your leadership, and frankly, thank you for your partnership, even going back to our time in Congress together where we tried to demonstrate that Democrats and Republicans can actually work together. And I really appreciate your partnership and your persistent service to this country, whether it's as a NASA administrator or in Congress or in the Navy prior to that. Thank you for your service. For those who are watching, I also just want to say, to me, this is a really exciting opportunity. And it's also about the role that the United States plays. Before I came to Congress, I spent a decade working in economic development in Tacoma. And we had a sign up on the wall that said, we're competing with everyone, everywhere, every day, forever. And I have that sign a similar sign in my office in Washington, D.C., because I think it's a pretty good reminder that we need to keep our eye on the prize. There are a lot of folks sitting in capitals all over the world trying to figure out how to outcompete the United States, especially when it comes to science and technology and innovation. And we've faced that competition before, and frankly, the space race was a big part of how we demonstrated our capacity to drive innovation and to have a national mission. You go back to Sputnik, in 1957, when a satellite the size of a beach ball was launched into orbit by the then Soviet Union, and it was a wake-up call for our country. And after that, our nation acknowledged the global competition that we were in, and we responded with investments in research and in infrastructure and in education and in innovation. It became a national mission, and I hope we have a mission again focused on helping young people compete and helping us identify new technologies and make new discoveries and drive new innovation. And for every student who's watching this, please know you are a part of that, and that there are great opportunities also economically. Everything that goes up needs to be built here on the ground, and there's economic opportunities in that regard too. So please keep at it with the right education. All of you on this call today can help us win that race, and as your member of Congress, I'm doing all I can to help achieve that. So again, to Administrator Bridenstine and Dr. Barrett and the whole team at NASA, thank you so much for being here, and thanks to all the students for joining and for all the great questions. And Administrator Bridenstine, I'll let you have the final word.
Well, I want to just thank you, Congressman Kilmer, my friend Derek. I appreciate all of your leadership in space. I just have to ask a question. I can't really tell. Is that a Boba Fett helmet behind you?
That is a Boba Fett helmet behind me.
So it's not just your congressional office where you have Star Wars paraphernalia. It's also okay. Fantastic. All right. Well, again, I appreciate your enthusiasm for America's space agenda, which of course is not new, but it's been ongoing. And I'm thrilled that we had so many students participate in this. And again, it's up to us to make sure that another generation doesn't go by where we don't have people living and working on another world, and we want to continue to use these advancements to ultimately put humans on Mars. I think it can happen in our lifetimes, not just in our lifetimes. It can happen in the next, I would say, by the mid-2030s. Again, budget's dependent, and I know there's a lot of competing priorities there. I'm not suggesting there aren't, but it is very real that in the not too distant future we could have boots on Mars. The first step to getting there is to get to the moon, prove that we can do it for long periods of time using the resources of the moon, and then taking what we learn there and preparing for that mission to Mars. So Representative Kilmer, thank you for your leadership. Thank you for hosting this, and we'll look forward to catching up in Washington, D.C. here in the not too distant future.
Thanks, everybody. Bye-bye.
Bye, everybody.
Thank you all for joining. This concludes the event.